draft physics video. Yeah, a couple of subjects, probably a mixture of things. We'll see. I'm in a mood. So, just this really shouldn't be so difficult to argue theories. And a lot of things have been running through my head. Just watching an old, one of these, whatever, talking heads of physics, Brian Cox. Looks like he's 15. He's like 45. Amazing. Anyway, just but it's just the physics is just so they're so convoluted and buried it all in stuff that nobody can ever look at. So nobody can really look at the evidence for like the Higgs boson or something. We're not going to be able to analyze it and say where you might have made a mistake here, you might have made a mistake there, you might have drawn a conclusion there, say anything like that. Or even in the description of the model. And then they write these equations that are just, layers of equations that just have symbols for other equations. And they make it seem like, oh yeah, see, it's only this much problem. And it's not, no, it's a lot more of a problem than that. So it's just inaccessible to the average person. So he has to take it all on faith. And, part of the problem with that is that there's fewer minds working on it, or looking for holes in it, or debugging it, so to speak. So it's just a little club that gets to catch their mistakes, and nobody else gets to play along. And that's a big problem with complex models, because not enough people are going to have the wherewithal to understand enough of the model to be able to understand when something's not right in it. So anyway, so this gravitational lensing subject is sort of an example of that. And then there's lots of things people can think of, and there's no fact sheet somewhere that deals with all of that. Not that I've ever heard of. No place no repository of the little talking head theorists and their understanding and their own effort to see what flaws they can find in their theory. So anyway, so I was just as an little add-on. So no one responded to the question video with an answer of how this isn't a catastrophic problem for gravitational lensing, in terms of there's no evidence of the consequence of lensing, which is that in most cases, in like 99 out of 100, or maybe even 999,000 out of 999 out of 1,000 cases, what we'll see is not something extra we get to see of the universe, but we'll actually see something deleted from the universe. So 9 times out of 10, the effect of lensing will be something we won't see, not something we will see, because of this whole focus issue. So, as pointed out, if you're going to say something can lens this distant from an object, then everything here is all stronger gravity. And it means that every photon that goes in here doesn't go where it was going. So all of these views have been deleted, essentially, from the universe to create all of these views from these different focuses. And that goes for objects of different placements. All of the views for all of these objects would be deleted. So no matter where it was, how far it was from the lens, or how far the observer would be, all of those views are deleted from this perspective, or this perspective through the lens. So looking through the lens, you shouldn't see anything behind the lens from this angle, because everything's been destroyed in terms of your view, unless you go somewhere over here. So you might be able to see something that's over here, over here, but you won't see anything where it's supposed to be. behind this lens. And that'll happen 9 times, 9 out of 10 times. That's going to be the effect you're going to encounter, or 99% of the time, that's going to be the effect you're going to see. Not the 1% when you have the exact right distance for you to see the lensing. So the point is that this negative effect of lensing would be the dominant effect, the one that will have more effect on your view of the universe. So that makes it even a more powerful point, that if lensing actually happened, then there should be a ton of things disappearing, half images, all of that stuff in the wrong places, lots of stuff in the wrong places. So yeah, I think it's a catastrophic flaw in their theory. Anyway, so we'll do some comments and maybe some magnetism and electricity stuff in terms of the movement of fields and the idea of the creation of an eddy current, which I don't think is actually what happens. So yeah, thinking about it, I think I'm getting closer to a better explanation for the different effects. And it can sort of be seen in the difference between, the ferrous, the non-magnetic material, versus the paramagnetic, so copper versus, say, steel. And clearly the magnetic field created when you bring a magnet near steel is the opposite magnetic field. It's complementary. So this sticks to the steel because the steel creates an opposite magnetic field, not a opposing field. And in something like copper, it's an opposing field. And the trick is that it's ahead of the movement, so, yeah, which is kind of obvious. If you approach something with a light bulb and you're moving it, obviously the light's going to affect the surface ahead of you, ahead of where you're moving. And that's why it's felt as some sort of reaction to neutralize. It's not really doing that. It's just that it's creating the complement. It's creating the same field through pressure, not the movement of domains. So I guess that's where I wanted to get to. So you have to understand, when you're doing it with magnetism, when you're moving a magnetic field, you're doing two things. You're going to affect it if it has domains. You're going to affect the domains, and they're going to line up with the magnet. But the pressure thing is just going to affect the electrons and the protons, and that's going to be a complementary field. I mean, it's going to be the same magnetic field. It's going to be hostile to the magnetic field you're pushing into the conductor or the material. All right, probably need a picture for that one. Okay. Anyway, so anyway, the Michael Falwell guy. I think it's a blind guy. Yeah. So he says, listen to a few more of your videos, and the fundamental notion of pressure and polarity being the key players makes perfect sense. Yes, I realize that too. I tried to envisage a pull force creating an attraction repulsive force, which seems much more elaborate. Yeah, you can't really, I couldn't make one up in my brain. Pull always has to be, if you're going to try to make a simple pull, it always has to be some sort of magic. Otherwise you have to make something with hands. Creating, let's see, much more elaborate, but the pressure being either external, pushing bodies together, or between the bodies pushing apart, simply explains attraction and repulsion from a single push force. Yeah, if you start with a pressurized field, then it's just the movement of that pressure, but it's always push. I was thinking that if if you want to unify forces, well, I think I've already done that, but anyway, perhaps the EM spectrum should be rebranded the E spectrum, energy spectrum. So yeah, I would rather keep it connected to the fact that it's just the spectrum of things moving at a frequency, because that's all it is. So magnetism and gravity don't function at a frequency, and magnetism's a huge source in some sense of, it's used as a way of converting energy. So I guess saying it's a source of energy would be the wrong thing to say, but obviously the magnetons, the gravitons converted to magnetons, are the force, and they're as real as any of the other photons that are the electromagnetic spectrum. It's just they don't do the frequency thing. So yeah, so I think I need some other, I mean, I certainly wouldn't call it the energy spectrum, because that's denying gravity what it is, which is high pressure. Anyway, we have come to know and love are all on this very large scale, very broad spectrum, and hopefully there is more forces to discover in the future. Well, I don't know where you're going to find more forces. I don't know why you're hoping to find more. Yeah, I don't think there's more forces. The whole geometry thing, as you know, my origin of sight is useless. Organ of sight. But I do have a mind's eye. Yeah, well, the geometry thing is, to put it simply, the big universe is doing this rounded thing, but there really is no such thing. Even the round objects aren't really round. It's all, at least, it's all straight line geometry. The forces all move in straight lines. So anything that's moving a curved path only appears curved because you can't see the little jagged lines, the staircase that it's really moving, essentially. So they're really, it's all square geometry. The circle is an illusion, so not a real thing. I guess that's why pi doesn't work out as a number. It's because a circle isn't a real thing. It's a lie. It's not really a circle. It's like a zillioctaton or something. Zillioctaton? Yeah, something like that. Anyway, moving on. But I do have a mind's eye. Very often I can see geometric shapes and symmetrical patterns. Yeah, well, like I said, the idea of the circle being easily represented as 4 right turns or 4 left turns. Just the idea of the square is just as circular as the circle. I think possibly this is something that is ingrained into the human consciousness. Well, I don't know about that, without realizing it. I just think obviously we have a lot of geometry in our worlds that we interact with. But like I say, most of that geometry isn't reflective of what's going on the little scale. The little scale is simpler, and it's not doing all these crooked lines. It's not doing curves. And we look for these patterns in everything because it's a, let's see, presupposed human trait. But that is a human condition, and the universe is not human, so this could be where misinterpretation and mistakes may occur. Yes, it's best not to anthropomorphize physics and put any elves in it or anything. But yeah, no, I think these are sort of important things. I just have to be more articulate in describing the essentialness of the idea of push being more likely more probable than push as a first act of, as a first um, initiation of something energetic, something creating movement or exchanging movement. And again, the simple geometry of a square versus the complex geometry of a circle. I was also thinking about paths, straight and or bending. Yeah, well, the bending stuff is just loop-de-doo, so I don't think there's any useful, I don't think it has any useful purpose in doing the, tiny world. The tiny world is probably very, very square. I couldn't do this personally, but if you look at a blank piece of paper and a craft knife and you have a good dexterity, you could cut a path of elaborate swirls, spirals, circles, arcs, for example, and that's how they would appear if you and everyone else, but that path is cut with a perfectly straight edge blade. Well, that's probably another way of saying that on the small scale, the knife's cutting straight lines, theoretically. But yeah, it gets a little messy. Like I say, it's what we can form matter into in the big world. Is it something you should think that the small world works that way, especially considering how the forces are so manifestly straight line in their function. I know I'm more on the philosophy side of things, but hope you can understand that it's harder for me with the science side. I don't know. Well, it's harder for you, everything. So I can understand that. I don't know if geometry maybe is something that might be something you can still model without sight. But anyway. Alright, so Steve Irwin asks, am I on the air? I don't know what that could possibly mean, but it doesn't matter. Then Hoffaday chimes in with pointless drivel. Don't forget the phenomenon of resistance and heat generation. I said those two words in the video. So, due to the flow of electricity. Yeah. I said those words in the video. I wasn't forgetting them. So, delete. Jesus. Alright, now the Scientific Lee guy is, I've sort of been polite and said, I'm really not here for you to post your propaganda on my videos. I have no intent of going on your videos and, selling my theory. It's not really the way I think the world should work. So I think you should just respect the fact that I'm arguing with conventional science, not truther kooks. Okay? And you're a kook, from my perspective. I mean, the religious thing already makes you a kook, an idiot, untrustworthy, gullible, stupid. I mean, what do you want to say? You're already in a category of moron, but you fell for that crap. The silliest story ever written. So you have very low credibility points right there. And then what you're talking is just silly. And it's got curved lines all over the place, and as I just pointed out, I'm kind of a straight line kind of guy. And I sort of understand how the forces all interact in straight lines. So all your little loop-de-doopy stuff doesn't go anywhere with me. We're never gonna see much on the same way. So, all this mush is just not worth it. So he posts like 6 comments on one video. It's the same video. I mean, these are all rules. You can't follow them? Okay. I mean, apparently you don't listen to my videos very well because I think I've already told you this. Alright, so he says, leaves the charge behind. I don't know exactly what that means. Imagine if it was water. No. The connection would pull the same way. If that helps you visualize it. No, I don't like the whole idea of fields. I don't like the connection. Leaves the charge behind. I just don't know what the fuck he was referring to. It's just not enough of a quote. Oh, fuck that. Alright, so then it says, wind and current are both from energy moving. Well, I don't know what wind has to do with any of this. Are you, you are correct in your insight, as there is no wind. Good. Only energy moving. I'm not sure about that. I don't trust you. Yes, there's quanta moving. Same with water and current and air and all matter. Well, if it was all the same, then you wouldn't have names for like electrons and protons. So that's just sort of mushy talk. Alright. So he says, atoms are magnets. Smiley face thing. Okay. Not all atoms are. In the sense they don't create polarization that extends beyond them. They don't filter anything because they're not arranged properly to magnify their effect. If they all don't line up, then they're not soldiers technically. They're not going to create magnetism. All matter is a focus point of energy. I don't even know what the fuck that means. I mean, it's just, what do people do this stuff? All matter is a focus point of energy. Matter is pierced by the ether in all directions, creating a magnet and other matter. Why don't you draw a picture of the ether? What are you talking about? All chemical reactions are due to magnetic attraction. Well, that's probably correct. And rotation of a magnetic field. Changes in the field. I don't know about rotation, tricky word. Pulling on one thing or repelling another. Well, again, pulling it doesn't really do. It just has low pressure, the absence of push. And then the outside push takes over and does the going in for you. But there's no pulling. You are doing very well, bro. So you obviously don't know me very well, because I really don't... I don't go for this dude stuff, bro stuff, boy, buddy. None of that shit. I don't do that. Homie don't play that. So don't do it. An electromagnet will increase its shape by fractals. Pile of crap that is. Same as ferrofluid is either. Little peaks are one huge dome. It just has to do with which way the gravity's moving. You know, but whatever. I mean, the fluid is a fluid. It has to be obedient to gravity, and so gravity creates its shape. If it was in zero gravity, then you'd see its real shape, the real shape of the force. More energy in, question mark. Larger field appears. A nuclear bomb, quote unquote, is electrified to ignite it. Sorry, not even close. It rises the EM field and destroys all the EM field expansion. Whatever. So whatever this is, see, that kind of remark has absolutely nothing to do with my theory, and it has nothing to do with established theory. And those are the only two things that are really relevant for now. You know, once my theory is the established theory, then I'll take on all comers. But till then, my objective is the horse in front of me, not the horses behind me. No. Alright, so Michael again. Let's see. Hi again. A little confused on this one. So this is the quickie on lensing. How you describe what they say lensing is doing is kind of strange to call it lensing. No, it really isn't. Lensing, a lens bends light. So, and it bends it to a focus. if that helps. I mean, I'm trying to think of how I should describe it to somebody who maybe hasn't seen a lens, you know. But it's a light bender. I mean, that's all you really need to know. And it bends it to specific angular percentages, depending on how where you're located in the disc that is the lens. And that's what the gravitational lens is, the same thing. It's just that the disc is huge, okay, and they claim, and they're using the gravity as the bending mechanism, where in a glass lens it would be about the surface configurations that would dictate the angle of the bending. Alright, how you call it lensing. It would be better defined as mirroring at an angle. Well, there's no mirroring, so that's not lensing. That's the only way you could get one image and not be in its correct sightline path, but reflected off at an angle to another viewpoint. It's just about moving photons that were going one way and deflecting them so they go some other way. So they're going straight and you bend them some degree percentage. Now those photons are changed in their direction. They don't go where they were going because now they're going somewhere else. They can't go to both places. Right, if it were straight line path but reflected off at an angle, let's see, mirroring at an angle, that's the only way you could get one image. Yeah, I just don't know what he was saying there. It would be better defined as mirroring at an angle. That's the only way you could get one image to not be in its correct sightline path, but reflected off at an angle to another viewpoint. Well, again, that's what a lens does. So it's lensing. Lenses change the path of photons, just like the gravitational lens. If it was lensing, both observers would see an image, albeit a little distorted through the lens. That's wrong. I mean, that's not correct. Regular optical lenses will create blind spots. Spots you can't view through. You won't see anything through them at an angle. I mean, I have a lens here. I mean, I know you can't see it. If you look through it at an angle, you're not going to get a view of anything but stuff in all kinds of wrong places. You know, but you're not going to see through the lens in specific locations. You can actually see the frame of the lens when you tilt it enough. Anyway, let's go through this a little further. The straight line path observer would get a better image as the light would continue on through the lens, and the other would be deflected image and angle, and that would be seen elsewhere. Well, the real point is that if you're talking about lensing in the sense of there's an object and the object is blocking your view of something else, and now you're going to see this something that's blocked by bending light that was going somewhere else. So the point is, it's certainly light that was going somewhere else that you're going to be seeing. So there's no way to get around that. If there's enough gravity to bend the light, it's going to bend all the light. Some of the photons don't get to be special photons that aren't bent. They either all get bent or none of them get bent. But there's not going to be any, oh, I got through the gravity and I didn't get bent. You know. No, if there's lensing gravity, that's it. You got lensed. You're moving. You're going somewhere else. There's no choice, and there's no some of them get through thing. All right. So J. Ash said, also, if photons are supposedly affected by gravity, wouldn't the photons that provide us with an image of, say, the sun reach us later than they should? Yeah, well, that's a subject, you know, this whole idea that their gravity, right, which is supposed to be the Higgs field, but it really isn't, right? The Higgs field just gives other things mass, but it doesn't give photons mass. So there are all these catches and everything. And certainly the bent space somehow does bend the photons, though. So the Higgs can't get to the photons, but somehow the bent space does. But anyway, yes, and that's one of their catches, right? So they just made up a rule that says, no, you can move it side to side, you can't move it forward and back. So, you know, they made up their own rule and said, no, we can affect photons side to side, but we can't affect them forward and back. So you can't give them more speed or less speed, which seems to break conservation laws, but who cares about those, right? Would they not be moving slower as they leave the sun's surface and then reach the speed of light as they travel further away? Well, again, the very idea of photons being like the little train that could and having some sort of variable speed doesn't really work as an idea, in my opinion. So obviously, yeah, I don't think that's true, but I also don't think you can bend a photon side to side either. It seems to me that if such a time discrepancy exists, you could measure the effect. Well, obviously, your supposition is wrong. They don't think photons can be moved forward and back. They only think they can move side to side. Gravity can't make them go faster or slower. Alright, so then this Magnus Rudeness, he left some other comment I deleted because it was just absolute trash. I mean, just not a single counter argument or anything on the subject, just trash about how I have no right to have an opinion. So fuck this guy. Let's see, J. Ash, Internet Fool. The light is fucking affected by gravitational lensing. The wavelength does a redshift as it travels away from a gravity well. So again, this is their theory, that redshift is something that happens to light after it's on its way. So that's one of the things this Brian Cox guy was talking about, you know, the expansion of the universe and the fact that it's somehow stretches the individual photons. You know, and I wonder how exactly it does that. Because that sounds silly, right? I mean, each individual photon gets stretched the proper amount. Yeah, doesn't sound logical to me. But anyway, you are dangerously lazy, unintelligent, and far too overconfident in your ability to understand something that took the smartest man 1,000s of years to figure out. Smartest men. Well, they really didn't get anywhere close to this kind of shit, you know, until like 300 years ago, so I wouldn't exaggerate. Speaking of exaggeration and overconfident, you know. So Jay asks the Magnus, geez, why do you respond like that? Well, because he's a stupid, ignorant troll, and he can't do any better. He can't actually argue or explain. He just has to sit there and declare everybody else an imbecile, and he thinks he's so smart. You know. He doesn't even have a proper icon. You know, I mean, his icon is one of the old style YouTube icons. It's not even a letter. Let's see, then I don't know what this stuff is, you know, these people. I mean, this was on one of the videos to Ken Wheeler. One can only deny what he can define. Yeah, oh, that's just so interesting. He's another guy with Greek statue as an icon. Yeah, that's just so profound. Pathetic. Alright, so let's see, what do I want to do? I just don't know if I want to argue the, you know, I mean, there's really only two parts of this video that were something to argue, and the first one was the expansion argument. You're just saying how many complications does the idea of creating expansion create? I mean, when you think about it, because you're expanding the space inside the atoms too, and the space between the electrons. And if they just ignore that expansion in the space, because they kind of have to or the atom falls apart, then in some ways they have to be traveling faster than the speed of light. It creates all kinds of paradoxes. That is totally unproductive to talk in those terms, when what you're really describing is just the fact that yeah, I don't even want to give it that much credibility, because they base it all on this redshift argument. So if it wasn't for the redshift, all of this wouldn't even be talked about. So because most of the crap in the universe appears to be moving away from us, because it's redshifted, or we're moving away from it, and that seems kind of impossible to move away from everything, in a circle. If you're in a circle and you move away from everything, it's kind of hard to do. But a lot of the stuff, like I said, isn't really everything. But instead of saying, well, maybe we don't quite understand redshift, they just go with this idea that, okay, let's just pretend everything's expanding. And I guess I would argue that I can buy the argument that everything's moving away from each other, and they can only do that as material things, not as photons, because photons do the straight line thing. So the material bits are moving away from each other because they're still moving. The real direction they're moving is that way, out. Okay, it's because they're going out at different angles. We're all heading out. And because we're heading out at slightly different angles, it looks like we're moving apart from each other. But we're really not. Again, and that's the matter bits. I just don't think the energy bits could possibly be doing that, because they wouldn't be able to create pressure. So it's sort of irrelevant to the structural bits. And that's where the photons live. That's the world they live in. So you certainly aren't going to stretch them, because they're not going to be affected by that, the movement of the big bits. Yeah, that's probably a better way to say it. But that's another thing. It probably needs a picture. And the other things is the Higgs field, and then getting into a conversation about Einstein's relativity, without even saying, well, he said bent space-time, but I mean, it's just this whole idea of, there's such a contradiction in talking about the Higgs field, giving everything except photons mass. So, and then having that somehow coexist with the idea of bent space, because that's giving things mass. So is bent space the Higgs field? I mean, what's the you can't have two sources of quote unquote gravity. It just seems like they're making two. Or maybe the Higgs field is just a replacement for what I was talking about, in the sense that they are calling it the Higgs field, and what it really is this density of gravitons, little bits. And the little bits don't interact with force, they only interact with matter. And it's that interaction that they're calling giving something mass. See, that's the real mistake, is they think mass is something to do with momentum. And they don't really understand. See, they think things can have zero standing mass and then some kind of moving mass. But it's technically you're not going to have zero standing mass, because your standing mass, if you're standing in one place, it means that the forces are just balanced inside of you. But you certainly still have mass, just like I have mass sitting here. Gravity's working. You throw me up in the air, gravity's going to throw me back down. So gravity sees my mass. All right. So I don't know if, that's stuff for another day, I suppose. But yeah, I mean, both of those starting points, I think there's plenty of room to do lots of debating on what exactly they have as evidence that says it's got to be this way. And I think there's lots of detail where there can be lots of devils to pluck out, and just be nice to have a fair fight doing that. Because I think my counter theory fits the evidence better, more efficiently, and just makes more sense. Or physical, again, back to that word. Physics is really supposed to be about physical stuff, not fields of woo. Alright, what else do I need to do here? So yeah, the electricity thing was sort of simple, so maybe I'll do a quick little picture of what I was thinking. Alright, so you got two ideas. You have the idea of the fact that there's materials that have, you know, magnetic domains inside of them. So they already have atoms that are already magnetic, in the sense that they create a good differentiation between their proton side and their electron side, and whether they flip or they just change that arrangement. So I guess if I drew, let's see, yeah, maybe I'll just draw it and then I can illustrate it. Alright. Yeah. So say there was a relationship you know, between atoms, where the atom can be defined in in two ways. It can be defined like it has this unevenness, like one electron's really close to the proton, one's very far away, and vice versa, or likewise in this circumstance. And so you can see that instead of this having to flip all the way over here, what you could do is just exchange the force. Take the force that's here and put it over here, and then the electron that's over here, the one that's far away, ends up further from the proton, and this one ends up closer. And so the point would be is that in one of these arrangements you have a really good dipole. And so those would be your dipoles, is which side the close electron is on, kind of a thing. So anyway, so those would be the domains, that are the atomic elements that line up, and you end up, like all magnets, I would argue, are just a bunch of little magnets on the inside of the material. So magnetism is just how many of the atoms are lining up, creating lots of little magnets. By percentage of the atoms, the higher that percentage that are doing the little magnet thing, the stronger the material is in terms of being a magnet. And again, something like steel or some other material, you can line up the atoms a certain way, and they can stay in that configuration. If you don't whack them or heat them up too much or something else, then they'll stay in that arrangement. But anyway, so that's one thing that's happening. The other thing that's happening is what we call electricity, okay, which is, I might have to make it black on the surface because it's going to be electrons, which is the idea that when you bring a magnet in proximity to a conductor, and so you're doing two things. So if this magnet, you know, I have to probably, it's always best to do the red-black thing. So if I bring this magnet in proximity to the conductor, one thing it's doing is it's going to line up domains that are going to be opposite to the magnet. You know, that's the way magnets do. They flip. So they're going to flip to be, you know, the force is going to be exchanged anyway. The end result's going to be is they're going to tend to line up conducive to the magnetism that they're being affected by, which means they're going to try to attract, in the sense that they're going to line up opposite to the arrangement that's coming in, just like a compass needle will do. So they're going to polarize opposite in the domains. But the other thing that's happening is this force is coming in, at these lines reach all the way out of the magnet. And so what happens is this ends up creating that electron pressure here. So the electrons are getting pushed. And so this automatically becomes a voltage magnet, in the sense that there's more electrons at this end than there are at this end. And you can sort of see the electrons at this end, because of the redness, are going to be ended up moving this way. So there's going to be clearly a low voltage here and a high pressure here. So high voltage, or low pressure more accurately. And that's essentially the same as a magnet, because you're collecting black, which means you're putting it closer and closer together, which means that it's essentially like the magnet. It's going to be filtering the gravity forces that go through, and so you're going to end up with more of the black stuff here. So these two are going to oppose each other, and that's going to create what's a magnetic torque. So if this magnet's moving, and it's going to induce a magnet ahead of itself, and that magnet ahead of itself is going to be repulsive. And so as it gets closer and closer to the magnet it's creating, it's going to feel more and more pressure as it gets higher to higher voltage, higher pressure anyway. And so that's going to create a pressure that's going to slow this magnet, an opposite torque on the magnet. However you want to describe that. But that's the consequence. That's the price you pay for pushing electrons. It takes energy to push them, so it makes sense that there would be a torque on the magnet, because you are actually doing work. You're pushing electrons. Stupid little frickin' mouse in the house. Ugh. Go away. No squatting here. Bastards. Anyway, yeah, so that's where I am right now. So there's really two things that happen. So in a piece of steel, the dominant thing is the domains. They're really powerful, because they can, in steel, a lot of them can line up and can become a very powerful magnet through just the domain switching. So the current pressure is almost irrelevant, because the magnetic domain creation is going to be the much stronger force. Now if this was a piece of copper, the domains are really weak. It creates a very weak capacity to line up the domains, so that isn't going to happen. So all you've got is the electron pressure that you're going to be creating. And so there'll be no attraction. It'll just be the repulsive force. So I think if you actually do take a round magnet and put it in a round piece of copper, I think it's true that the magnet never hits the sides. It just goes through slowly, right through the middle, because it's always repulsive to the magnetic field being created. The magnetic field it's dropping slower through is a hostile field, not an attractive field. Stop it! Stomping helps sometimes. It's chewing my house. There's no nutritional value, you know. You fucker. Here, listen. You hear that? Yeah. Fucker. You'd think my presence alone, would be enough to say, oh, I'm not going to live with that guy. Anyway. It's just, well, whatever. Life is difficult here. Anyway, I think that's all. So I think I'll just say that's enough for until next time. Yeah, so it's just this whole chore of, I am trying to solicit a real physicist to have an interaction with, offering money. That's what you got to do. But we'll see. It really needs to be somebody who matters. That's the tricky part, is getting somebody who has better things to do, to provoke interest in some character who, somehow I have to make them think it's in their interest. I mean, I think it could be interesting. So, I mean, I think it should be, like, say if they can't, oh man, I've done all the subjects, I'm completely out of physics subjects, this might be a good idea. They think, oh yeah, I'll have an argue with some, science, pseudo-science truther nut. And, but obviously they don't realize they're going to lose the argument. And, they're going to look like the nut. But anyway. Otherwise, it's back to the whole publishing thing, and that's just such a, you can just smell the gatekeepers. They don't know what the fuck what do they know about physics? The gatekeepers of the publishing community. Because these talking heads don't, are just talking shit. But anyway, we'll get to that. Yeah. So, until next time. Sorry, a bit tired.